1, 2. Okay. Am I live? What's going on? Hopefully this works. Okay. Hi everyone. Today we'll be working again on the Fluke 5700 series calibrator and hopefully get some more progress. And before any of that happens, I'll need to clean this mess. I was doing some checks and inventory counts. So let's get unrelated things out of the way. Some of the voltage reference boards. Ultra low noise power supply board for Keithley 1801. So we don't need this today. This moves to the secret location. Okay, this was another test. It's GRL 1 ohm resistor, basically 4 of them, and I was doing some temperature stability testing. We'll get back to that later as well. This is another unfinished, I would rather say not started project. I wanted to do high power 1 ohm resistor, so I'll use 4 of those, and this is VHP 4 1 ohm resistor mounted on the heatsink to have like 2 amp rated ultra stable 1 ohm resistance shunt. And this module is Keithley 7168 nanovolt scanner. So it have 8 channels and plugs into 7001 Keithley and allowed to scan stuff like voltage references. Alright. This is regular TC scan. So if somebody watched previous live streams about this project, I had front panel disconnected, so this wire harness which connects the calibrator output to the front terminals. I think I'll zoom in on that. So what we'll need to do is to connect all these wires to the posts, so we can actually connect the external reference and try to run the calibration and see if we can calibrate the calibrator. But before we do that, I think we will upgrade the firmware for digital board to change for the different firmware. I wanted to try Fluke 57 EP firmware, which is essentially brings all the functions and specs of the 5720 unit, but it still shows 57 model name. So that firmware is essentially designed for units that have upgraded hardware but still have 5700 front panel. We don't have the 5720 hardware yet, but we can work on that in the future videos. And the firmware upgrade is not that hard, it's just a little time consuming because we need to install missing ROMs. So let me show you. This is the original firmware. We have 4 ROM chips, and then 5720 and 5700 EP use 2 additional ROMs, this one and this one. And also there is SRAM allocation, we don't need those. And this empty space is for another UART chip for debug purposes. We don't need that either. So what I'll need to do is to solder 2 sockets, and I already programmed all the chips. So just replace these 4 and put 2 new chips in there. That's what we will do. And it should take maybe half an hour or so. Okay. And I already have really nice collet type sockets. And program the firmware chips. This is a brand new OTP firmware, I think Atmel AT27C010, if I remember correctly. I just bought them from DigiKey. Still available in a deep package, no problems. Okay, and I'm looking for stuff again. First we can put the chips which are already socketed. Still trying to relocate all the tools and equipment in the lab, so I'm not sure where is my proper deep chip extractor, so I'll just use barbarian way with the screwdriver. There we go, U15. There's our U15. U17. U16. The original date codes on the EEPROMs is B93336, which means week 36 of 1993. It's rather old. Here we go. This we don't need anymore. These are, yeah, I think they have a window. Let's see. That's the original firmware chips. These are UV erasable in the ceramic package, but we can keep them for a later date in case we need to roll back. I think it will be okay. So now we just need to put these two sockets, and we should be all ready to go. Okay. I think I'll use my method with the toothpick to make the holes, and then just put the socket, solder it. Should not take much time. And I'll have to use the fume extractor, so sorry for the noise on that. like that. Get a closer look. Let me change the lens for that. Oh, yeah. There we go. I actually did try to run the self-calibration check a couple days ago, and it's actually passed, so hopefully that means we can run external calibration as well. But probably it will not be as easy as I hope so. We'll see how it goes. And calibration usually takes about 1 hour, and using 3 standards: 1 ohm, 10 kilo ohm, and 10 volts. What calibrator does during this process is using external known standard values. It will calculate internal references and use those as check standards for all the functions and all the ranges. That's why you see so many relays and additional hardware on all of these calibrator modules. One chip is one footprint is done, so we'll have to get the second one right here, and then we're ready to go. Okay, last hole. done. Should be good enough. Okay. Let's put the sockets. Okay, 2 holes need more work. Okay. Right, one is done. And I think we're done. So looking good. Let's put now U24. Here we go. And U23. Okay. Now we can put the card in. Let's plug the card in. Back into where it belongs. And now we connect all of those to the front panel. I think I'll also use new posts because these are old and ugly. But before that, we change the lens again. Oops, yep. There we go. Let's see. So I'll have to remove the front panel. There we go. There we go. That's better. this cable goes like that. I have to remove this. Well, before we mount that, I think we'll change the post. So let's do that first. And when working with the copper nuts and copper hardware, you need to keep in mind that it is soft and easy to break. So we don't want to over tighten, or that can damage custom posts and connectors. And the reason for using soft copper in here is low thermals. So when you have the signals connected at the junctions, if you have different metals like bronze and copper wires, you will have parasitic thermocouples. And by using only copper connections and only copper hardware like nuts and bolts and all that, you minimize that parasitic effect of additional thermocouples where you don't want them. This is especially important for precision instruments like this one, which can source very small signals down in microvolt levels. Here is the post. I think I can have a closer look on this. There we go. The problem with the copper hardware is that it, on the open air, it oxidizes. So normally every time you need to use this type of connections, you need to clean the surfaces, and only then you can use them. Otherwise you will have even worse problem, because the copper oxide and copper give horrible temperature coefficient, much worse than similar metals. Okay, so now we have forget one more. This is chassis connection. Now we can clean this mess a little bit. This is also all of, this is not a separate part, it's all piece of the same plastic piece, plastic mold. Yes, that should be Tellurium-Copper. I also like to use the oxide for the copper connections. It works quite well. But I don't really care much about this front panel, because this one will be all replaced with the new one, so that's not really a problem. We just want to have nice connection. You can see how much crud and stuff. We want just to have nice connection for this quick test, because I still don't have my new front panel. I think it's on the way. Also, there is some part of the sticker, limited cal. We don't need that anymore. Looks a little bit better. Alright, but now it's time to find the new post. I think I saw them not too long time ago. The question is where? is the part of the reason why I hate moving the lab around, because then you cannot find anything for a quite long time. But I guess it's part of the process. Let's see if I have all the right colors. That's the old one. That's the new one. So we have red, we have green, another red, and another red, and yeah, we can have all red and the green. Or we can look in another secret shed. But there are no posts here. Not the right ones, at least. Okay. Well, we can go with reds. That will work no any different than we would expect, so the posts also have small notch, so they don't turn around and destroy everything when they are in locked position. Let's get that right. Also, it would be a good idea not to use bare fingers, but actually use gloves, so you don't contaminate the metal surface with skin oils and stuff like that. But again, all this will be replaced anyway, so that's why I'm not doing it here. But if I would be doing this for real, I would use the gloves. Okay, like 1/8 of the turn, just to make sure it's all secure. That should be all right. Now we can put the rest of the hardware. Can the ultrasonic cleaner renew the connectors? Well, it depends on how dirty they are, because if there is like oxidation and stuff, then you would need something to take that off first, and just ultrasonic will not help much. But if it's just like surface contamination, then probably yes. But in this case it would be hard to ultrasonic, because you will need to remove the plastic part, and that's the whole frame, it's not just this piece. But I guess I could try ultrasonic in some future video to confirm or deny that idea. So we could try that. All right. I think this is not the last time when you see me connecting the posts on the calibrator, because I plan to do it with the correct front panel in future. By the way, is the sound okay? I turned the volume even lower on this live stream, hopefully to remove most of the noise of equipment running right behind me. Alright, let's figure out where goes what. So I think I'll just use one of my older pictures. There we go. Okay. And I actually already have an article about calibrator like this one, not exactly this one, but same model. And you can find one at my website, xdevs.com/fix/f5700A. And it shows the picture of every board and various parts of different boards, and also how the whole assembly looks like. And it's a great article showing many aspects of this calibrator. Alright, so we can connect the easy one. Yellow is the current terminal, and the connection is you have the washer, then spade lock with the cable, then another washer, and then the nut. So everything stays nice and secure. And remember, not to over tighten. And high output is green and blue. Let's find green and blue. And the reason why two wires, because they are coming from different assemblies. So you have two wires. Okay, this is our high connection, and output low, that would be green shield, blue shield, and gray. So this is green shield, gray, and yes, so this three goes in here. Like this. Maybe this one goes first. It's a little tricky. There we go. And this one as well. Something like that. That should be good enough. Now we need to have high sense, which is brown wire, and then brown shield and violet connects to the low sense. This is easy. And then this SMA port next to it is wideband output option. It's SMA to N bulkhead connector. we don't have the wideband option in this calibrator, so we can leave it unconnected, or I can just terminate it to the cable, which goes... did I put the washer in? Yes, I did. I have too many washers left. Maybe I missed one. Yeah, I guess I have the input in here. And oh, we still have this not connected. Okay, let's not get distracted. Don't like how this wire goes. Well, I don't use this tool for anything other than connecting the connectors like this. This is not a mechanic workshop after all, so we don't use oils and stuff like that on the tools. This is metrology lab. Well, supposed to be as one, but it's still pretty far from metrology. Just a hobby home lab. Here in Taiwan I have to run the air conditioner pretty much 24/7 for the room where is all the equipment located. Otherwise ambient temperature will become quickly around 32, 33 C, and that's not very nice for the gear. Okay, I think this is all ready to go. Let's check the connections. So this should be green and blue. Yes. Green shield, blue shield, and gray. Yes. This is yellow current, and shield is not connected. This is guard, which normally goes to the rear panel. And then we have brown for high sense, correct. And then purple or violet, and brown shield for the high sense, yes. And then this is just a guard, yes. Let's get the front panel back in and see if calibrator outputs anything. And if it does, then we can try and run some calibration. All right, let me change the lens. So this cable goes like that, wiggle, wiggle, and goes under the calibrator, where all the boards live. Okay. Here we're back in business. Let's put it all together. There is normally also a shield cover which shields all this high voltage noisy display stuff, but I don't have that in this front panel, so we will omit that for now. And I'll have to lift this a little. Bit tricky. Opa. There we go. All back in place, sorta. Okay. Now let's connect. Well, let's first power on and see if it works. Okay, so because we updated the firmware, it's become unhappy. Let me turn some light off so we can actually see better. Maybe just move the camera a little bit closer. Sorry about that. So this error shows that the new firmware doesn't like the old calibration ROM firmware format. So that's what it says, please format. So we can do format. Do you want to proceed and format all? We need to format all anyway. So yes. Of course this will completely erase all the calibration data. Format is complete. And I think we can power up and power cycle again to make sure there is no more error. And it says, yeah, this is 0 not calibrated, that's okay. 0 later. No error. I think we're good to go. Let me fix this light situation. Or you can actually see the screen. good enough. Let's see what calibrator says about the information. Okay, so now main revision is main LEP, means that it's Vision L EP version in guard B, model 5700A. And then it detected all the assemblies. That's all good. Let's see what it says. Instrument setup, and yeah, we can change the spec as usual. Spec confidence, yes, this function spec confidence, either 95% or 99%, is not present in 5700A calibrator, but it is in 5700 EP or 5720. So now we can choose the confidence. That is good, and let's do the self-test first. Self-test and run. It should give a bunch of errors because we have some assemblies missing. That is as expected. So we don't have A16, we don't have A15, and we don't have A14. So any errors related to that, we can just skip. Those are high voltage and power amplifier. So we will not have 220 volts range, 1 kilovolt range, and 2.2 amp range. But that's okay. Now another point is we want to keep the airflow through the calibrator, so I'll put just some piece to keep the airflow directed correctly, like so. So it doesn't overheat other stuff like high voltage power supply assemblies. And we can add a meter on top, so we can do some tests. It's a good old noisy Keithley 2002. And let me find the power cable for it. We have one. All right. Now what we can do is connect the inputs. Self-test going so well, so good. So let's use fancy Fluke connector cables. They are also using the copper material, as you can see. These cables are not cheap if you try to buy from Fluke. Oh, there is some error. Switch matrix relay fault. Okay. We can worry about that later. Okay, this should be good enough. Right now the calibrator output is not connected to anything, so you just see the random pickup on the Keithley meter. That is normal, nothing to worry about. It's very typical for people who are not using benchtop meters all the time to get alarmed by random readings jumping up and down when there is nothing connected on the front inputs of the high impedance meter, like this Keithley 2002. That is normal, and it's just picking up the charge and static electricity. And of course, if you use the high voltage ranges like 200 volts or 1 kilovolt, these ranges are terminated through a voltage divider, 10 mega ohm input divider, and that's why you see zero voltage, well, or close to zero. But if you go 20 volt range, then it's high impedance input, and then you see the charge picking up. That is completely normal. You can hear relays clicking and stuff. It's almost done. Well, maybe another 5 minutes. Then we can program 10 volts and see what happens. And I think we'll have some fun and use another calibrator to calibrate this calibrator. Because I already have the terminals connected. So we will use, oh, another error, A16. We don't have that board, that's okay. This is okay too, okay. And diagnostic is done. So we only had one error about the A8 relay. And that is a good news. And to calibrate this calibrator, we will use that calibrator right over there. Let me focus. This guy is all happy, and The largest changed 35% of the spec, that is 24-hour spec. And the calibration was done just a couple days ago at April 4:30. So we'll just connect the output of the calibrator, these spade lugs, to the input of our calibrator under test. But before that, let's check that all the functions at least somewhat working, and that we can at least have some hope. So let's set 0 volts and output. Yay, we have 0. That is pretty good. Now we can output 100 millivolts, 100 MV, enter. And indeed, we have something looks like 100 or so millivolts. We can do the negative. So I would expect to see the same value on the meter, just negative. Yes, it's pretty close. That is good news too. Because essentially the difference from the calibrator point of view, just switch the polarity on relay. Let's try 1 volt. Okay, 1 volt is working too. No problem. 10 volts. 10 volt is looking good. And we don't have the 100 volt range because there is no PA in this calibrator. So it will give us error. If I can type the buttons. Yes, it's outside and above of the output of the calibrator. That is normal. We can try 0 ohm. And in 4-wire mode, external sense. You cannot see because of the cable, but there is the 4-wire is when this button is light up. So we can do 0 ohms. Okay, that is pretty good 0. We can try 10 ohm. Okay, 1 kilo ohm. Okay, 100 kilo ohms. All right. Let's try 1.9 ohm. That is present as well. 19 ohm. Look at that. 190. 1.9K. 19K. 19 kilo ohm. Okay, all good. 100 mega ohm. 100, 100 mega ohm. It's only 2-wire mode, so we need to disable the sense. 100 mega ohm. There it is, a little bit noisy, but that's okay. Let's try some AC voltage. 1 volt, 1 kilohertz. Okay. The value is about the same as the DC voltage. That is okay because the units have erased calibration. So to get the correct amplitude and the correct outputs, we will need to calibrate it. Let's try 10 kilohertz. Okay, looking good. 20. 100 kilohertz. Looking good. 1 megahertz. Not bad at all. And 10 hertz. It's the lowest the calibrator can go. I think I'll need to set some filters on the meter, but 100 hertz, no problems. Let's try some current. DC current, 1 milliamp, 0 hertz, output normal, it's all good. Yep, the current is output as well. 10 milliamps, 100 milliamp, 100 microamp, negative, it's all good. Let's try, there is no 1 amp range because there is no PA boards. Let's try AC current, 1 milliamp, 1 kilohertz, output, yep. So looking good. So let's do the calibration 0. Yeah, it's only 17 minutes, but it's okay. We don't really care about absolute accuracy at this point. And while it's doing that, the inputs are not connected to anything, so it doesn't really matter what we do here. And we will connect the other calibrator to the input of this calibrator. So let's do exactly that. High and low. Now high and low sense. And then the guard. Provide some shielding, and yeah, it will be better if I do like that. Fluke is already using non-standard pitch between the connectors, so I wish they would add some little bit more spacing just to make the connections easier, but oh well. And this is essentially the same cable that Fluke using for the calibration cables, which is, let me find the model. It is Belden cable. Yes, it's Belden M8719. Okay, 0 calibration is done. That is good sign. So in this step, calibrator used internal short, 4-wire short, to correct all the offsets of the 0 output. So now we can do the actual calibration, or at least we can try to. And it gives you a warning that you're trying to calibrate too fast without the warm-up time. That is okay for now. And now we can do the calibration. So it will ask you for the ambient temperature. Right now we have around 24 C. Let's do enter 24C, and now it's asking for the 10 volt reference, so we can program our first calibrator. Let me adjust the camera somewhat so you can see stuff. So I'll set this calibrator 10 volts and output. So now we have accurate 10 volts plus minus 2.3 ppms relative to the standard I used in the calibration. And now we can enter 10 volts for this guy. 10 0 0 0 0. Any questions, guys? This takes a little bit of time. I think the next step is oh, battery is out, but I'm ready for it. Maybe just another year of doing XDev stuff, and then I'll have enough donations to buy a proper camera for the YouTube live streams. The next step is actually minus 10 volts. It's just to correct the linearity issues. So that's what the calibrator will ask. There is a question in the live stream. I saw an older calibrator in the last video which had the red front panel. And yes, that is well, there is a calibrator right behind all that, sitting under that scope. That is Time Electronics 9823. So that's like five and a half digit calibrator, and that was my first unit I was playing with. I bought it broken and fixed it. Well, mostly fixed it. Still have a couple issues. But now that I have these flukes, I'll be selling that calibrator. And yeah, I don't use it much. It's very limited on the AC voltage. But the benefit of it, it's very small, well, compared to the 5700 series. And also have 10 amp range. It's also have resistances up to, I think, 1 mega ohm or 10 mega ohm. No, 1 mega ohm. So it's quite nice meter, quite nice calibrator, and totally capable to test and calibrate like 5.5 and 4.5 digit equipment. Okay, we get the 10 volt calibrated. Now let's do the negative. I'll just inverse the voltage on the source calibrator. Proceed. It's asks you reverse polarity on the reference connection to the binding post. Okay, let's say we do that and press enter. Now we do the negative corrections. Okay, that passed as well. Let's do now 10 kilo ohm and 10 kilo ohm, because 5700 series calibrators, they are not using synthesized resistance like the 5500 series, so we will have to use the value which is recorded on the calibrator from its calibration. So 10 kilo ohm is actually 9 kilo ohm, 999 ohms, 635. So we use external sense and we operate. So this is our reference value, and spec of that is 6.5 ppm. Again, relative to the standard, and the standard in this case I was using my Fluke FSL 935, which is the black box in the crate on the right side. I have it calibrated against the US lab just last year, so I still have good value for resistance, and we will enter this into our box. Adjust the camera just a little bit, yeah, like so. So let's enter that value, 9999 ohms and 635. That's our 10K. We can play with the secret menu game first, while all this is calibrating. A little Easter egg in the Keithley 2002. Here's another one. And of course there are also credit messages. Probably used in the demo floors and stuff like that. Okay, 10 kilo ohm is calibrated. Now we need to calibrate our 1 ohm. Whoop. let's do that. 1 ohm. Now it's 0.9998221 ohms. So let's remember this value and type in on the calibrator requested values. Proceed. 0.9998221 ohms. Okay. Now this step takes about maybe 5 minutes, and then there is actually a very long calibration step, which is using internal references and calibrating all the functions and ranges on fully optioned calibrator. That takes around 1 hour. And everybody can welcome Todd. He's a mastermind behind all this Fluke madness. Still going? Okay, 1 ohm is calibrated. That 1.9 ohm is interesting value at 0 ppms. It's hard to believe, but like, okay, let's proceed, I guess. Now all the main calibration steps will be executed, and that takes a while. So do you guys want to keep going with this live stream, watching for this thing, or should we call it a day and finish on this moment? What do you guys say? Because the calibration actually takes like almost, I think, maybe 50 minutes or 40 minutes, because we don't have the high voltage option and high current option. I'm not sure what I can do here in the lab to occupy all that time. So, what's your call, people? I know there are 10 people watching this, so it's up to you. It's about noon time here in Taiwan. So I guess it's midnight in somewhere in US. And what I can do, I can probably swap the resistors for the test in the temperature chamber. So that would be one thing to do. I can show that. If I can get the camera adjusted. So where is that light in the corner? There is a box with the temperature chamber. And we don't need connections to calibrator anymore, so we can disconnect this wire. Doing the tests with new resistors from Belorussia, and results are promising so far. This is just a styrofoam box with the tech temperature chamber. And then I just put the resistors inside, program the temperature I want, and slowly increase the temperature or decrease it, and measure the resistance change. And the resistors, these are the resistors. This is 120 ohm, this is divider, 1 kilo ohm, 13 kilo ohm. For the LTZ circuit. And also this is a, let's carefully put it down. This is a bare element, 10K. This is 10 kilo ohm bare element. I put it on the copper slug so it's easier to handle. Well, calibrator is still going. That is good. So what I'll need to do is to change at least these resistors and this one. All right. Guess we can do that. The calibrator is back to ACV convergence tests and calibrations. Okay. These are the resistors I'm going to test now. Oops. Not sure if you can see. There's 75 kilo ohms. And these some more bare elements. And these resistors are similar to the foil technology, but made a little bit differently. And also they are not glued to the carrier, but welded to the ceramic plate instead. Quite different design to what we use. So I got some sample to test them and to see what's their performance is. And these are specified for 1 ppm per degree. So let's get to it. And all of these are 4-wire connection. So that is not required for the LTZ reference. Just a nice touch. So this is the 120 ohm, which I tested. And now I'll connect this 75K. They are rather big. I can put some other resistor for comparison. Like, for example, where is that box? Like here, for example, is the typical VHP foil resistor. That one is 40K from HP board. And this is Edwin's Ultra Ohm wire bond resistor. This one is S102. You can see how really huge these ones are. You can put like, it's like 8 times bigger. Well, and then there is VHP 518. So that should give you a good comparison. And this is Russian MPX 1.8 mega ohm. And I can also put even bigger one for comparison. It's a real beast of a resistor. It's the Rooks Isabellen Hut 2 milliohms, 1 ppm per degree, 100 watt resistor. So there you have it, different resistors. Let's come in this nice package. All right. Calibrator still calibrating. Didn't throw the error yet. Let's connect the cable. This is that divider I was talking about earlier. Nope. There we go. Divider is essentially two of these elements connected together. So it's like double of the thickness. There is single. I have to separate my 4-wire cable. Okay. Data about the previous ones, 1K, 13K and 120 ohm is actually already posted on the EV blog in metrology section by David. So yeah, there we go. This is 75K. Now we connect another one. Need to be gentle with these terminals. They are pure copper. And quite soft. There we go. Also, it's important to solder quick, so you don't heat the element too much. Now we need to put these two guys into the chamber. Let's see if I have enough cable. Maybe I turn that light off. Let's see. Yeah, that should be better. So let's check that everything works. $200K for wire. Let's do 5 digits. Okay. Looks okay. I can do full resolution and also configure the HP meter. It's the bottom one. Okay, that one is fine, and that one is okay too. Looking good. Calibrator is testing resistances and calibrating them. Alright, now we put everything into box. We can disconnect this one. And this is okay. Let's test bits and pieces of this Fluke resistor which shattered from unknown reasons. see if it still somewhat works. Where are the probes? Well, still something works. I guess I can connect it to here and see how well it works. You can actually see that calibrator we're talking about earlier. I can move. And hide it from the equipment. There you have it. So we can connect it to power. So can output really straightforward to use. So this would be I already forget, that's DC voltage. How to select, this is 10 volt range, and it also goes up to 20 volts, even, yeah, 20 volts. That's the full scale, I think 21. Let's see. Yep, 20.9999. We have 100 volts, 1 kilovolt range, 100 volt, 100 millivolt, 10 millivolt. Can do resistance. So that's in kilo ohms. So it's 10 ohm, 100 ohm, 1K, 10K, 100K, 1 meg, and 10 meg. And then for current have 100 microamp, 1 milliamp, and so on, up to 10 amps. And for AC it's limited to 60 Hz for high power, high voltage, and up to, no, high voltage actually AC can do 1 kilohertz. And I think it's only 20 kilohertz for the lower voltages. So there you have it. It's all controlled by GPIB. Quite nice calibrator for its what it cost. But of course it's not a competitor for the Fluke 5700 series. All right. And no, I am not soldering on top of the meter. There is a metal stencil. Okay, I've connected the element, a piece of it. Let's see. Can turn the guy off. Oh, it lost its memory. Oh, my hotkeys. Interesting. Even though resistor is not hermetic anymore, it still shows 1.7K, 1.71, as it's supposed to be. All right. Can do. I'll check on this guy just to make sure everything's okay. Go back to our calibrator project and see what it does. Still working. That is a good sign. Calibrating resistors. And meanwhile, select and resistance ranges to do the test on that. Okay. Keithley and third meter. Let me see. So that should be 200K. Meter 3 have that. Okay, so we still have one more resistor to connect. What should we connect? Maybe this guy. Okay. Resistance elements are back in chamber. And I'll run the test from 16 degrees plus 16 to plus 50. That should give us some good data on the temperature coefficient results. Oops, my camera. Sorry about that. That's a small live stream accident. Okay, now there is a problem. And I think I remember this one. It's because there are some constants not correct from the formatted EEPROM, and we'll need to replicate that. And of course this error, 4500 error, is not the service manual. So it's quite hard to get exactly understanding what is it doing. I think that's it. So I'll do all that offline and we'll show the results on EEV blog. And also be sure to check the articles on xdevs.com. Thanks for watching. Bye.